This is similar to the previous question. In fact, the converse of the previous question. Here, ABCD is given a quadrilateral. I've drawn ABCD as any quadrilateral, which intersect each other at point, the diagonals, right? The diagonals here, AC and BD intersect at point O. And further, the information is given that the sides are in this ratio, that is AO upon BO is equal to given CO upon OD. We have to show that ABCD is a trapezium. As you can see, I have drawn the figures looking like a trapezium so that we find it easier to prove this are trapezium. Here these lines are not given parallel. We in fact have to prove these two lines parallel, as we know that if two lines are parallel in a quadrilateral, if one pair of opposite sides are parallel, then it is a trapezium. So let's see how we can prove this trapezium. For that, we will draw from O, we will draw a line. We'll draw a line, say OM, parallel to say AB. Now we will consider this triangle and we'll apply BPT here. So in triangle, we have this triangle. That means in triangle ABD, we have OM parallel to AB. OM parallel to AB. Therefore, from BPT, we can say that AM upon DM should be equal to OB upon OD. That is from BPT, and you can mark this equation as 1. Now let's write down the information given to you. There is another ratio that we know, which is AO upon BO is equal to CO upon DO. This is what given to you. This was given. Now, applying properties of ratio, we can reverse this and obtain a similar ratio to what we have been given. Try obtaining BO upon OD, and that is possible by applying the concepts of ratio. So we can reverse this and write AO upon CO. Right, bringing this here. AO upon CO is equal to OP upon OD, and mark this equation 2. Now from 1 and 2, what do you see here? That this is same as this, right? So from these two equations, that is from 1 and 2, from equation 1 and 2, what can we say? That AM upon DM is equal to AO upon CO. Right? You can see here, since these two are equal, so we can write the other two. That means we can write AM upon DN is equal to AO upon DO. Once we write this, we can consider this in triangle. Let's consider this in this other triangle. By this, I mean to say the triangle this time I'm taking is this one. In this triangle, we have AM upon DN is equal to AO upon DO. So by converse of BPT, now we will be applying converse of BPT. So what does the converse of BPT says that? By applying converse of BPT, you can say that this is OM parallel to DC. Right? So this is equation 3. Now check here in the construction, right? In the construction, what we have written? We have written OM parallel, right? There is a construction here, which I told you that we have drawn OM parallel to AB. Right? Through O, we have drawn a line OM parallel to AB, which intersect AD at M. Now this from here and here, right? From this and this. What do we conclude? That two lines which are parallel to the same line are parallel to each other. That means we got AM as parallel. Oh, sorry. This is something wrong I did. This was AB. This was AB. Right. So from these two equations, what do we get? We have OM parallel to AB here and here. OM parallel to DC. Can we use it? Once again, this is OM parallel to AB and here OM is parallel to DC. So from these two equations, we can say that AB will be parallel to CD. This line AB will be parallel to CD. And once we prove these two, we can say that ABCD is a trapezium. Reason being, a quadrilateral whose one pair of opposite sides are parallel is a trapezium.